5-7. Today we're going to be talking about adding and subtracting unlike fractions. Now, for you guys, this is going to be a review lesson because you've done it in 7th and in 6th grade. However, I want to make sure that you are really focusing on fixing those little mistakes that you made possibly before, and we're going to be adding on eventually with variables and different skills like that, okay? But we need to make sure that we feel very comfortable with the basics so that we can move on. So let's go ahead and review how to do that. So, in order to add and subtract fractions with unlike denominators, we would first need to make sure to get the denominators the same by finding the LCD. So last lesson we talked about the LCM, the least common multiple. We also touched on least common denominators. So basically the least common denominator is the denominator. You look at the two unlike denominators and then you find the least common multiple between them. So basically we need to make sure that our denominators are the same and we change our numerators accordingly. And then we solve, whether it's adding or subtracting or adding negative numbers or anything like that. And then you simplify at the end. So always check to make sure your answer is in simplest form because you always have to have it in simplest form. Alright, let's look at two examples up here. I have one example that is just regular fractions and we're adding them. So first, when you look at a problem like this, you have to realize that the denominators are not the same. So we're going to have to go ahead and find the least common denominator. Now in this particular case, both of these numbers are prime, so you just multiply them together. So 5 times 3 gives you 15, so I know the LCD is 15. Now how do I change my fraction accordingly? So I went ahead and I put each of my fractions in parentheses just so that I can keep my thoughts organized. So maybe this isn't the best way to organize it for you, but I do suggest that you find some way to keep your work neat. So I realized that in order to get 15 in the denominator over here, I have to multiply by 5. So I have to do the same thing in the numerator to keep it the same fraction. So I did 5 times 1, which gave me 5, 5 times 3, which gives me 15. Then I looked at this fraction over here, and I kind of kept it in parentheses as well. And I saw that in order to make my denominator 15 over here, like I did over here, I'd have to multiply by 3. So 3 times 5 gives me 15. And then 3 times 2 gives me 6, which is my new numerator to keep our equations balanced. So now let's go ahead and add across. So then 5 plus 6 gives you 11. 15 plus 15, the denominators stay the same, so you don't have to add the denominators. And then we have to look to make sure it's simplified. Now in the numerator I have a prime number 11, and so I know I can't simplify anymore, so I'm good. Alright, let's go ahead and look at an example where we have mixed numbers and we're subtracting. So the first step that you need to do is make your fractions improper. So we want just a numerator and a denominator. We don't have to deal with the hassle of our whole numbers or anything like that. So we're just going to go ahead and make them improper fractions. So multiply and then add. So 6 times 2 gives you 12 plus 1, which gives you 13. And that's my new numerator. So 13 over 2. And then over here I did 5 times 4, which gives me 20, plus 1, which gives me 21. So now we're at the same spot where we were up here. So now let's go ahead and find the LCD, or the least common denominator, because both 2 and 5, they are not the same. So we're going to have to go ahead and find the least common denominator. And just like over here, where both these numbers were prime, we multiplied them together, we're going to have to do the same thing here. Since 2 and 5 are prime, we can't break them down anymore. You multiply them together, you'll get your new least common denominator, which is 10. So now, let's go ahead and change our fractions to make sure our denominators are the same. So we're going to go ahead and I organize mine with parentheses as well so I don't get confused. And I realized that in order to get the 2 a 10, we need to multiply by 5. So 2 times 5, which gives me 10. And then I have to multiply the numerator by the same number. So 5 times 13 gives me 65. So 65 over 10 is my new equivalent fraction. And over here, we need to look to see how do we get 5 to 10 in the denominator. So I know I have to multiply by 2, so 5 times 2 gives me 10, and then I have to multiply the numerator by 2 as well to keep it equivalent. So 21 times 2 gives me 42. Or 21 times 2 gives me 42. Now let's go ahead and subtract our numerators. Now be very careful of your sign here. You don't want to mess up just because you added or subtracted wrong. So then we did 65 minus 42, which gives us 23 over 10. And I went ahead and made it a mixed number. And I don't have anything else to take out over here. So it's 2 3/10 or 23 over 10. Alright, now let's actually try to do some ourselves. Let's go ahead and look at our first example. This example, first, what I kind of want you to do is really look at the problem. because you can miss little things like negatives out in the front and things like that. You do not want to do that because that will change your complete answer. You don't want to do that. So I'm looking, both of these are positive and we're adding. Okay, that's good. I've done my evaluation. Now I'm going to look at the denominators, and obviously they're not the same because we're dealing with fractions that don't have the same denominators. So I'm going to go ahead and do my little work over here, and we're going to find the least common multiple between 4 and 14. So we have to recall what we did last lesson. It doesn't go away. We're still building on that. So 4 is 2 times 2, and then we have 14, which is 2 times 7. So let's look at them. We have 2 squared, and we have 2 times 7. So remember, we have to write down all of the numbers represented. So we have a 2 represented, and we have a 7 represented. Now we need to make sure that each of our numbers are raised to the highest power possible in this problem. So we look at our 2's. We have a 2 raised to the second power and a 2 raised to the first power. And since the 2 raised to the second power is bigger, then it wins. So it beats the other one. So we're going to raise it to the second power. And then we have 7 raised to the first power, so we're good. So 2 squared, which gives you 4, times 7, which gives you 28. So this is our goal, to get our denominators equal to 28. So now I'm going to go ahead and multiply. 4 times 1 gives you 28, 4 times 7. And then we also have to multiply the numerator by 7. Now let's go ahead and look at 14. How do we get 28 from 14? We have to realize that we have to double it, so we'll multiply it by 2. Do both the numerator and the denominator the same way. So now let's go ahead and write our new fractions. We have 7 times 3, which gives you 21 over 28, plus 5 times 2, which gives you 10 over 28. Now let's go ahead and add. We have 21 plus 10, which is going to give us 31 over 28. So now you can either put it in mixed number form, or you can leave it as an improper fraction. In this example, I'm going to leave it, and I know that there's nothing else I can take out, so here's your answer, 31 over 28. All right, let's go ahead and look at another example. Now, in this example, let's go ahead and look at everything we're dealing with here. I know a lot of times you're going to want to just dive into a problem, but sometimes that's a mistake because you're going to miss something very important. So let's look at it. We have 3 and 3/5. All right, it's a mixed number, so I'm going to have to change it to an improper fraction. I'm getting that in my head. Plus, okay, we're adding a negative number. So we're adding a negative number. If you recall back to the lessons when we did adding and subtracting integers, adding a negative is the same thing as subtracting, because you're just saying, okay, I had this, and then I'm going to take something away. So we're going to take, so basically we're subtracting in this problem. We have 4 and 5/6. So now, I'm going to go ahead and change both of these mixed numbers into improper fractions. So we have 5 times 3, which gives you 15, plus 3, which gives you 18 over 5, plus a negative. 6 times 4 gives you 24, plus 5 gives you 29 over 6. And now I'm going to go ahead and find the least common denominator between 5 and 6. So we have a 5, we have a 6, 5 cannot be broken down anymore, so 5 times 1, that's it. And then we have 6, which is 2 times 3, so 2 times 3. So now we have to write down all of the numbers represented. We have a 5, a 2, a 3, and nothing is raised to another power, and so we're going to get 30. You can also think of it as 5 and 6, when you break them down, they have no numbers in common, so you just multiply them together, and that'll give you your new common denominator. So we have 30. So now let's think about it. 5 times what gives you 30? So 5 times 6, so we also have to multiply the numerator by 6 as well. And I'm going to erase this so I can just keep all of it in the parentheses. So now I'm going to have to think of 6 times what gives you 30? So multiply by 5. And then multiply by 5 in the numerator. Now, I just kind of want to touch on this a little bit because I saw some of this in the last lesson when you guys were, you added to get to your new denominator, but you can never add. We have to multiply because we're just multiplying it. We're not changing it by adding. So, let's go ahead and multiply them out. I'm going to kind of do my work off to the side. I have 18 times 6. So 6 times 8 gives you 48. 6 times 1 gives you 6 plus 4 gives you 10. So now we have 108 over 30. So that's done. And I'm going to go ahead just right here to change our plus and minus, or plus and negative, to a subtraction sign, because we know that we're subtracting in the long run. So now let's go ahead and do 29 times 5. So I'm going to do my work over here. 29 times 5. 5 times 9 gives you 45. 5 times 2 gives you 10, plus 4 gives you 14. So we have 145 over 30. So now we're going to go ahead and subtract. But I notice my numerators. I'm subtracting more than I have, so I know that my final answer is going to be negative, because if you ever take out more money than what you have, you're going to be in the negatives and things like that. So I know my answer is going to be negative, so I'm going to go ahead and subtract them on the side. 108. So 145 minus 108. Let's go ahead and 3 and then 7. So we have 37 over 30. Or you could write it as a negative 1 and 7 over 30. Write that as well. Either or.